We came up with this idea of making a hockey team. So people are now wearing their Canucks jerseys. And the hat is missing today. So there's this idea that you can make a team and just give it a name, and then you start filling out your roster by adding people to the team. And sooner or later you want to print out the roster, so there's the for each that prints out the roster. What's the sneakiness that makes that work? You can't run a for each on that team unless... Yeah, if you go back and look at team, it has to say implements iterable. And when you say implements iterable, that means you're writing something that looks like that. And when you want to write something that looks like that, it turns out we don't know how to do it yet, but we know somebody who does. So we'll just ask ArrayList to manufacture whatever's necessary, and then we'll send it back. Okay, so that's the same really as running a for each on ArrayList, and ArrayList somehow magically does that. So all that we're doing is we're sending that capability to the outside world so that people can run the for each through the list themselves. Okay, so that's what makes the for each works. And then we started in this idea of, okay, well, somebody could come along if we started to play and score a goal. And the interesting thing about when somebody scores a goal is that they pass in a hockey player that matches. They say, hey, I saw Daniel Sedin score a goal. This is like passing in the jersey and saying, hey, I saw this jersey score this goal. Okay? It's not the same one as the one that went in the first place, because there's a different new on that. So they're two different new things. Okay? So what we're going to have to do is go through the team's roster of all those players that were added, search for somebody who looks like this one, dig them out of the list, and say, hey, you scored a goal. Okay? So if we go into the team class and have a look, when somebody scores a goal, there's the looks like hockey player coming in, so that's the fake jersey. And in this case, all that we do to do the search for is call index of. So index of is the magic, let me search for things for you, and we pass in the one that looks like the one we're trying to find and ask it to find the matching one. Well, then the issue becomes, how does index of know anything about hockey players? And it can't possibly know anything about hockey players, can't really know anything about what it's searching for. So we have to provide some method for matching this looks like one against all of the ones that are already on this all players list. The way the matching is done is to drop the matching function inside of the hockey player class, because it makes sense for a hockey player to try to match against something that looks like another hockey player to decide whether or not it's found the correct one. So if we go into the hockey player class, the hockey player specifically has an equals method that overrides the existing equals. The existing equals matches by identical. And what we're trying to do is relax the restriction and say, well, they don't have to be identical, they just have to be similar. Okay? And so this thing, the easiest way to read it is if you ignore all the gobbledygook, it says, I think hockey players are similar or match if their first names and last names match. Okay? That's all that that thing means. Okay? So anytime you see equals, think similar to or matches, and the reason for a match is both their first name and last name match. And so as long as you write it in this little format, it's really easy to say, oh, okay, it looks like its first name and match and last name are the things that make it true, and if they don't match, it's false. Okay? If you had some other reason like middle names in here, you would just throw in, if middle names don't match, that's another reason to kick it out. And what you're left for eventually is match. Okay? If you ever decide that you're going to use index of, the rule is chances are probably pretty good that you should have written an equals method inside of the HockeyPlayer class or whatever you're trying to search for. If you don't write that, it's not going to find a match because it's looking for identical. Okay? So as a general rule, most of the time what we'll do is we'll write this for people so that they can use it later on with HockeyPlayers to match. Okay, so it becomes the job of the HockeyPlayer class to say, okay, if I'm writing all of these things, I need an equals method, just like I need getters and setters and all of those sorts of things, because that's a handy function for people to have. Okay, so if we go back and look and say, well, what happens when team says score a goal? Well, first it goes and it asks the array list to find the one that matches that's actually on the team roster. What you get back from array list is, oh, position 5 matched, which is sort of useless. So you immediately turn around and say, well, okay, go get me position 5. So ask the list to give you back position 5. That gives you back the person who was actually put on the list in the first place. And we go to that one and say, hey, you scored a goal. Okay, questions about that? The question is, how come you don't have to say return? For things that have void on them, you don't have to say return. It's only things that actually have a value that you have to say, specifically need to send something back. Okay, so we've managed to get HockeyPlayer so that we'll recognize goals. Let's go back and do assists. So we'll add in another variable that deals with assists, which means that assists needs to be set to 0, and assists probably needs to be included in the toString, which we didn't write, which is fine. We'll write a public int get assists so that people can inquire as to how many assists we had. And I guess we need to write add assist or scored assist. And that causes that variable to go up. So there's the setter. Okay. So if we've got goals and assists, what's the question you ask about HockeyPlayers? If you want to find out which HockeyPlayer is better than another, or how well they're doing. The total, which is really get total points. So points for HockeyPlayers are goals plus assists. Okay. In the old days, I think goals used to be worth twice as much as assists, and then they changed it so that they're the same. So notice the joy here is that the HockeyPlayer is in charge of figuring out what it means to get points. That can be goals, goals plus assists, twice goals plus 1 point for assists. You can work in plus minus or whatever it happens to be. The job of this thing is just to figure out what the maximum is, or what the best value is out of that thing. Okay, so we can do get total points and return goals plus assists. Okay. Suppose that I wanted to get the total points for the team, to find out how many points my team had scored overall compared to your team. How would I go about doing that? Where am I, what file am I going to go to?
team should be the one asking, not should ask the hockey player. Should ask all the hockey players.
There's two ways to do this. One way is to have the main program go through each of the players and dig out one of the players, ask the team manager for the player, and then add up all of the values. But wouldn't it be nice if we could do it the other way around and just say to the team manager, this my team variable, why don't you give me the total points? I don't care how you get it. Okay? So the trick of the game here is, rather than doing the work yourself, wouldn't it be nice if we could say total points is talk to my team and say, hey, go get me total points. And let it do the work. It's got all the hockey players. It might as well ask. So there's that idea again in Java. Push the work down to a lower level. Don't do the work yourself if you can avoid it. Okay, well, team needs get total points. What's my sneaky rule for when somebody asks you to send something back? First things first. You're going to have to send back a value. So let's make a variable. I guess total points is actually probably better. And let's set it to 0. And let's just send that thing back. By the way, now you could write a unit test and see whether or not it added up to the correct value, and the answer would be no. And once you've got it saying, oh, it doesn't give the right answer, you can go back and fix it to make it give the actual proper answer. Okay? So at least now you've got something to work with, even if the result is wrong. So now what? Got to go through all of the players, so that's a loop for, it's a player, someone in all of the players that are available. So all players is the array. Hockey player. Thank you. Now what?
Someone dot get total points plus equals someone dot get total points.
Do the simplest thing first. Who's holding on to the points? Someone is holding on to the points. So let's just go to someone and let's do get total points. And let's dig that out and put it into a variable. Okay? So I like doing one step at a time. So now I've asked the hockey player, how many points do you have? And now what's the next step?
Total points plus equals points.
Add it to how many points we've got already. Oops. You can combine those lines if you want, and most people who program probably would. They would just say total points plus equals someone dot get total points. But that's taking two different ideas and merging them together. The first question is, where do I get the information from? And the second question is, well, what do I do with it now that I've got it? Okay? And sometimes it's easier, particularly for beginning people, to break it down and write it into those two stages. And the other benefit of writing it into those two stages is that if you're running with the debugger, you can see the value that's coming and you can see it added into the other variable in the variables window.
What is this
Okay? So it's not such a bad idea to break up even things that seem like really simple expressions, because they'll make your life easier in the long run, both for writing it and for debugging it. Okay? So this thing will now have the team give back the total points, and so now in the driver, we can just go and find out how many points our team has got in total. Okay, well, back to the driver for a second. If I go through and print out the team afterwards, how would you like it sorted? How would you like the information displayed? You got a bunch of choices here, right? I mean, you could sort by total points, you could sort by goals, you could sort by last name, you could sort by first name if you wanted to be friendly with them. Okay? So there's lots of different ways to sort. So we have to pick one. So for the sort of way that we've been looking at it now, what seems to be the most appropriate way to sort? Since we've been working with points, I'd say it looks like we're interested in who's the best, so we should find a way to, when we print these things out, have them sorted by total points. Okay? So, if we're writing a for each statement, there's two ways that we can manage to keep these things in order. Okay? And I always like to use the example of people's rooms in their houses, like their bedrooms, right? Teenagers' rooms. Okay? How do teenagers normally keep their rooms in order? It's like not at all, right? And so what do they wait for before they put things in order? Somebody comes along and says, I want to go into your room, and then it's like there's this mass frenzy of, oh my God, I want to put things in order. Okay? So that's the normal sort of way for human beings to arrange things. You know, it's only the sort of the anally retentive people who say, I'm going to have my room in perfect order all the time, and anything new that comes in, I'm going to put it in order. Okay? So those are basically the two choices. You can either always keep things in order, and you can make sure that anytime you get a new thing, it's in proper order, or you can wait until somebody asks at the very end and do a mad scramble and keep things in order. Okay? So we've got two choices here. When people come in and score a goal in team, we could at this point say, oh, okay, after somebody's scored a goal, we need to make sure that everybody's in order. There's some new information coming in. The other alternative is to wait until people ask when we know that they're actually going to go and care to look, and then we can put things in order. And the thing that does the asking in our case is this function. Because whenever somebody runs a for each, they're calling the iterator, which basically means I want to go take a look and see what's in there. Okay? So you can either sort here after you get things in, or you can wait and you can sort here when people go and ask. Okay? Which one's easier? Which one's more efficient? There's a trick question.
First one.
The answer to the efficiency question is it depends how often people ask, right? If people open your door and ask every 3 seconds to see whether you keep throwing things in and checking to see if your room is in order, then you might as well sort it on the front end. But if people don't ask for a long time, then you might as well leave it messy, save yourself the trouble, and just sort once rather than continually trying to keep it in order. Okay? So there's no right answer to that question. It really just depends on how often you think people are going to ask. Okay? So in this case, the guess is that people aren't going to care when goals are scored. People are going to wait until the game is over or until a bunch of games are over, and then they're going to ask. And so at that point, we might as well do the sorting. So that's probably the place where we're going to do the sorting, is someplace in there. Okay? Now the question becomes, well, how do you sort? Well, collections.sort, we saw the other day, has the ability to sort. So we'll just pop in collections.sort, give it the list of things, and say, here, go ahead, sort away. Nice try, but we get an error message with a whole bunch of gobbledygook in it. Which means what? You need to implement that comparable thing. Translating the error message is basically saying, I don't know how to sort these things. Because sort doesn't know, should I sort it by first name, should I sort it by last name, should I sort it by points, has no idea. Okay? So we have to provide some function that tells it how to sort, just like we had to provide a function that told it how to go and match things. Okay? And this thing gives you a hint. It says that comparable word is important. So we'll go into HockeyPlayer and we'll say implements comparable. For HockeyPlayer only. And we try that, and it says you didn't provide that facility, you just said it was there. So we'll go to our friend the bulb and we'll say, please provide the method signature that I use, and it writes it at the bottom, and it says you need a compare to in order for it to work, and it just puts in one that basically does nothing. This O here, notice how bad the template was that it put in. It's sort of difficult to tell between O and 0. So this is actually some other HockeyPlayer, which is, I think, what they meant by the O. Okay. So, I'm a HockeyPlayer. Somebody comes along and introduces me to another HockeyPlayer. How do I decide who's better? What's the first question that comes to mind? Who has more points? Okay. What's the second question that comes to mind? I know it's got something to do with total points. So what information do I need at this point? We've got two people, me and the other person. So take the difference, but what are my points? I guess I could say my points is, I'll just use my get total points function since I've got it anyway, and call it from inside. There's my total points, just to be specific. What other information do I need? If I've got my points, other person's points, so let's do other total points. And that's other dot get total points. And then who's better? Take the difference of those two. I'll do it the long way again. That's my total points. Minus other total points. and then we'll just send back the difference. Okay? So if I've got 90 points and you've got 60 points, it's plus 30 points in my favor. If I've got 90 points and you've got 100 points, it's minus 10 points in your favor.
But now it says there it returns the difference, just a number.
Just a number.
How do we know which number corresponds to which one?
It's always me minus you. The question was, how do we know which corresponds to which one? If you always do this as my points minus your points, then you'll always end up with a positive number if I'm bigger and a negative number if I'm smaller. So if I'm greater than you are, if I'm bigger, then I get a bigger number, a positive number. If I'm less than you are, then I get a negative number. Okay, so positive means bigger in this case. You could write it the other way around, but that would mess up collections.sort. Okay, so just for fun, we'll go back to the driver now, and we'll add a bunch of points. So we'll let Daniel score 3 goals, and we'll let somebody else score an assist. We'll let Henry score an assist. Plop that one in there. And notice I'm purposely cutting and pasting so I get an exact match. And it's not called, oh, we haven't written scored assist. In team, well, that's really easy. We'll just take scored a goal, and we'll write scored assist. And we'll make sure that after we find a player, we say that player scored an assist. Done. Okay, and I'm just going to put a print statement in here. See whether or not I can get things in order of points, and run it, and we'll have a look and see what the point order comes out as. It says Roberto, Henry, and Daniel we can't see, so why don't we go back into the print line and also print out first name, last name, and actually I'll put points first. Get total points. Like so. So that we can see the order. And there's the order. So we gave Daniel 3, so he's in the lead. What order do you actually want them to come out in? The other way around? So how do we make them come out the other way around? If we go back and look in here, that's the place where we put them in order. So they're already in lowest to highest. If you want them highest to lowest, we've got our friend collections.reverse. And we'll reverse them. And then when we run the driver, they come out in proper order. Okay, so that's fairly typical. Before somebody sees them with the for each, we'll just make sure we put them in order by sorting them and then flipping them around. Get them highest to lowest. Okay, and the only way that sort is going to work is if you've got a compare to in the class, so that there's a default way of sorting them. Okay. Questions about that? Okay, let's make our lives a little bit more difficult then. Suppose that I want occasionally to just say, give me an alphabetical roster of people. So most of the time I put my team in points order because I'm interested in seeing who I should pay the most, but occasionally I just want to see all of the people I have on my team. Give me a list so that I can send a list to somebody. Okay? And I want that list now in alphabetical order by last name and then by first name, which is the standard way you would do alphabetical order. Now I've got a problem because in HockeyPlayer, you're only allowed one compare to, which is that one. So you only get one default order, and now I've got no way of writing another compare to that would give me a different order. So oops, this isn't going to work for me. I've got to find a different way to put these things in order. Okay. So let's talk about finding a different way. The way that I've written my compare to is it basically said, you're a hockey player, I'm going to give a compare to function to you so that if somebody gives you another hockey player, I can introduce the two of you and ask you who's the bigger one. And so you can think of the sort function as all that it's doing is it's running along and it's saying which one of you two is bigger. And then it takes the bigger one and it says which one of you two is bigger. So the sort function is doing the introductions. Okay? And the sort function is making use of the fact that this person knows how to compare itself to that person in order to do the bigger versus smaller.
Okay. You need to make a function that's compared to, but not
so
compared to.
Now I want a different order for these things. And I realize that as the sort function, I can't do this work anymore because I'm going to have to start asking people questions, and I'm too lazy to ask them questions about first names and last names. And I can't use the facility that's provided. What's the sneaky no work solution or minimum work solution to solving my problem? I don't want to do the work. I could ask them for their names, and I could go through the trouble of comparing names.
Or you could create another function that does the same thing that compare to does for this, but isn't compared to.
Think in terms of people terms. If I don't want to do the work, and those two aren't going to do the work for me, hire somebody else to do it. Okay, so what I'm going to do is I'm going to go hire somebody, and I'm going to put them between me and the people who are in the lineup, and I'm going to guide this person along through the lineup. What am I going to get them to do?
Compare them based on something else.
Compare them based on something else, but I'm still going to make the introductions. Okay, so rather than me introducing this person to this person, I'm going to go grab a third party, set them in between, and I'm going to say, I want you to find out which of those two people that I've introduced you to is bigger. And let that third party ask the questions, come up with an answer, and say, oh, that one says that they're bigger. Okay? And then I'll just walk my third party plus the bigger person down to the next person in line, and I'll say, hey, I want you to compare this person to this person and tell me who's bigger. Okay? So there's that trick all the time of saying, whenever I don't want to do any work, whenever I want to organize things differently, I'll just slide in an extra layer of workers, right, to do the work for me and let them ask the questions, and I'll just guide them along. So we're going to have to pull the same trick here we're going to have to provide somebody whose job it is to do the comparison for us in whatever way that they specify. Okay? Now, to make that work, I'm going to make our lives a little simpler. In this example, we've used team, and team just has a list of hockey players. What I'm going to do is I'm going to write a different main program, and I'm going to sort directly and use the facility directly so that you can see it, rather than having the intermediary of team. So let's just make a brand new driver program here. So we'll make a new class. You can put it in the same file if you want, or a different file. Might as well use this one. And I'm going to call this sorting driver, just so that you see the difference. Okay. And I'm going to make a list of hockey players directly, and then I'm going to add a bunch of people to that list directly. So I'm going to go steal that code from my other driver for a second. Wherever I added a bunch of people. Instead of doing that, I'm going to do it directly in the sorting driver by doing all players dot add instead. Got an extra bracket on the end, probably. Yep. Oops. Just a second here. What's it upset about? Oops, just that one. Yeah, thank you very much. That's because we haven't done the new array list that can only contain hockey players. And make sure we do the import statement for array list. Oops, I should have given them some points. How do I go about giving them some points? Notice that I added them to the list directly. I didn't keep track of them into a variable. So if I'm going to give them points, I would have to dig them out of the list again and give them points. So I'd have to go fetch the number 0 person off the list again in order to give them points. So you can put them on the list and fetch them back afterwards, or we can just keep a variable for our purposes up here, since I'm doing the short version. That's Henry. And then just add Henry. All I'm trying to do is manufacture some data here, so that's why I'm sort of cheating on my add. And then we'll give him some points first, which isn't normally the way you do it. Add goal. So we'll give him a goal or two. Scored goals. Probably without the S. There we go. So we'll just give him a few. And then we'll add them. And then we'll do the same thing for Roberto. I think I can probably just cheat on this. we'll give Henry one less goal, like so. And we won't give any to Daniel, just to make our lives a little quicker. And then we'll make sure we add Roberto. Okay, so we've got Daniel with no points, we've got Roberto with 2, and we've got Roberto with 3 and Henry with 2. So I'm just trying to get some test data where they're sort of mixed up. New hockey player needs to be Henry, this one needs to be Roberto. There we go, close enough. Okay. And then if we were just sorting these things directly, since we have the list directly, we would do collections.sort all players. Okay. And that's the point where it would sort players in what order?
Highest to lowest.
The highest to lowest by points. Actually, lowest to highest because we haven't reversed it. Okay, so someplace on the sort, I would like to say, don't do it in this order. I want you to do it in the default order. I want you to do it in a special order. So the way that you do that is you add an extra argument onto sort that says, ignore the default, use this way instead. Okay, and so we'll call it alternate sorter. Is just a variable name. Okay, so now I have to think of, well, how do I make an alternate sorter? Well, comparator by hockey player sorter equals new. Now I'm sort of stuck, so I'll make up a new alternate sort. And let me just put in this import of a comparator here. So the way that I'm going to make up, the way that we said we do the sort is we'd find another person and we get them to do the sorting for us. So we know that we've got to make another person, and another person in Java means make a new Java class. So I'm going to make a new alternate sort person. There's my thing that's going to do the sorting. There's a standard here that says that if you're going to do the sorting, you need to be able to do what's called a comparator rather than a compare to, in this case for HockeyPlayer. And just do the import statement. And that's the standard, right? I do alternate forms of comparison. And now it says, well, in order to do that, you're missing one of the unimplemented things that you need to do, and there's what you need to do. So this is HockeyPlayer really A and HockeyPlayer B. Okay, so this is a person who you can say, I want you to compare to hockey players. How does the person go about comparing two hockey players? By last name first. So we'll do it this way. String A's last name is talk to hockey player A and say, get last name. B's last name is talk to hockey player B and get their last name. We need the difference between their names, which is A last name wherever he went. A's last name compared to B last name. And then we could return the difference. Unless
This difference will be loaded to?
that's string comparison. So strings are going to return their difference in their alphabetical positions, which is fine. But what if they're the same last name? Then we have to do it by first name, right? So if they're already different, then we can just send back that difference. Otherwise, now we have to do the difference by first name. So I'm just going to steal that same code, plop it in here for the difference by first name. And then the difference will be A first name compared to B first name. Okay? So we'll try by last name. If they're already different, we're done. If they're the same, I'll move on and I'll try by first name and I'll just return the difference of that. Okay? And so now there's just this person whose only job in life is to say, given two hockey players with compare, figure out which of those two is different and give me back the size difference between them. Okay? That's their only job in life. And now when we go to sorting and we sort these people and then print them out, I'm just going to do a quick steal of our hockey driver had a for each that would work for us. That one will plop into the sorting driver and we'll print out all players. Save it, run it, and now we get Luongo, Daniel Sedin, and Henry Sedin. And so now they're in order of last name and then first name. Okay? So the bottom line becomes, oh, you have a standard sort, but if that doesn't work for you, you can always tell sort to use this sorting technique instead, and then you hand over a person to sort who's in charge of taking pairs of things and figuring out which one of them is bigger. And that person is specific to, in this case, hockey player. Okay?
And where do we specify that we want it for first name and last name on
It's done
the driver, right?
in the driver by saying to sort,
Compare.
you need to sort not just using the standard way, but here's the extra piece of information that you're going to need. Here's the person who's in charge of doing the comparison for you. Okay? And you make up one of those alternate sorters, and now you can make up any kind of alternate sorting you want. I could do another alternate sorter by first name where I just played with the code a little bit and I would have somebody by first name instead.
have to make another class for that?
You'd have to make another class because it's a different person who's now in charge of answering the questions in a different way. So yes, every time you want to do a different kind of sorting, you have to have a different one of these classes to do it in a different order.
Does that have to be made every time too? Does that has to be a new driver for every way you want it sorted?
Well, you would have different code to do a different kind of sort. So this alternate sorting would appear in a program in different ways, right? So every time you clicked on and said, I want it sorted by this column instead, then you would have a different sorter who was in charge of arranging it that way. And with that, we're done for the day.